Okay, so our computation finished. It took 81.6 seconds, so 1.4 minutes, minute and a half, so not too long. And we have our results down here. So we can visualize the orbitals. So this is similar to what we did with our C2 molecule, if you remember. So we can go down. Our lowest energy orbital is going to be our s orbital on our nitrogen. Once that loads, there we go. So it's our s orbital on our nitrogen. And then we're going to have various molecular orbitals that are spread throughout the molecule that relate to our different bonds that we have. So this is a, all the s electrons from the hydrogen and the two s electrons from the nitrogen combining to form a bonding orbital here. And then we'll have an anti-bond, not anti, this is still going to be a mostly bonding orbital. These are our p electrons interacting with the s. So our p orbital combined with s orbitals on the hydrogens. And we get something like similar here, but it'll be at a different angle. All right, and then we'll have another bonding type in orbital here. This is probably going to be, yeah, the p orbital pointed the other direction. It interacts a little bit with the hydrogens, but mostly the symmetry doesn't work out. And then we start to get to the anti-bonding orbitals. Right, and so this can tell us where the valence electrons are, located in this molecule and sort of what their shape is and things like that. So with the anti-bonding, we start getting crazy stuff like this. Right, so anyway, the other important thing we can look at are the vibrations. So if we click over here, it'll show us how, so at, these are in wave numbers, so it shows us at 3,604 wave numbers, roughly, right? So these are only approximate, and there are ways we can get more accurate results here. This is how the molecule vibrates. So this is an NH stretching mode. If we go down to some of the lower frequency ones, we should see some bending modes here. Yeah, so we get NH bending modes here. And we see we get some degenerate vibrations here. So this one at 1,000 wave numbers is right, the whole molecule kind of flopping up and down. And then we get some very low energy vibrations in ammonia that have to do with the whole molecule kind of twisting. So anyway, these are the sorts of things that we can sort of information we can get. We can click on thermo here. And if we scroll down, it tells us, right, some of the thermochemistry, right? So, what's the total energy of the electronic part, the translational part, vibration, rotation. So we see we have enthalpy, Gibbs energy, constant volume heat capacity, constant pressure heat capacity, entropy. And so, you can get all sorts of interesting information about our molecules from computational chemistry. And so this is an example of doing that for ammonia.